Let's look at an example of solving a triangle using law of cosine. In this example, we're given the length of the three sides of a triangle. We're told we're given that length. Side A has a length of 13, side B has a length of 6, and side C has a length of 15. So again, let's draw a triangle. Just to start off with, I'll draw my standard triangle, horizontal bottom side, and then two slanted sides extending upwards. I'll put angle A in the bottom left, angle B in the bottom right, and angle C at the top. So that means side A is on the right side, B is on the left, and C is on the bottom. Okay, this is not drawn to scale. This is sort of my general triangle. We know side A is 13, B is 6, and C is 15. So just to confirm and verify that we are looking at a law of cosine problem, just looking at the triangle, we know all three sides. That is side, 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 and that is law of cosine. So we are going to use law of cosine. All right, and just to write out one of the law of cosine equations, we know I'm going to use the one that looks similar to the Pythagorean theorem. I know c squared is equal to a squared plus b squared. So there's your Pythagorean theorem. So we have a squared plus b squared minus 2 times a times b times the cosine of c. Okay. Now, again, remember that don't get attached to the letters. We don't have to use a, b's, and c's. We can use whatever letters we want or no letters at all. Just look at the pattern of this equation because the pattern is the same for all the versions, the variations of this formula. Okay, so in this equation, side C is the side that's isolated, right? Well, what angle are we dealing with? If we have side C, then that means we're looking at angle C. So if I were to replace this with, say, we have a squared equals, what angle is going to go into the cosine? Angle A, right? So the isolated side in our equation matches the angle in the cosine of the equation. Okay, so if A is the isolated side, what do I fill in with the rest of the equation? Well, I can't use A and B because the A is the isolated side. So that means the rest of the equation is b squared plus c squared minus 2bc times the cosine of A. Okay, then we could do the same thing if we isolated the b side. Okay, so as long as you can keep track of the basic shape of this, the basic pattern of this equation, it's pretty easy to rewrite it, reorder it to match the equations that you want, okay, or the angles and stuff, the letters that you're using. So in this example, again, we're given all three sides, and so we need to find all three angles. We technically can only need to use the law of cosines twice to find two of the angles, and then once we find two angles, we can use the fact that they all three add up to 180 to find the third. So let's go ahead and do that really quick. Let's go with angle C. So again, c squared is equal to a squared plus b squared minus 2ab cosine of angle C. I know all three sides, so we're gonna, if I plug the sides into this equation, we'll have 15 squared is equal to 13 squared plus 6 squared minus 2 times 13 times 6 times the cosine of C. And again, C is the one we're trying to find. So let's go ahead and simplify this equation. 15 squared is 225. 13 squared is 169. 6 squared is 36. And then if we take 2 times 13 times 6, that will give us 6 times 13 is going to be 78. And so that's going to be minus 156. So we have 225 is equal to 169 plus 36 minus 56 cosine of C. We could combine like terms. So notice that this 156 is being multiplied by the cosine. So it is not like the other three numbers, the 225, 169, and 36. They are separate numbers, so we cannot right now combine that. But I can go ahead and add the 169 to the 36 and then subtract that result from 225. And so if I do that, 225 minus the 169 and the 36, I will get a 20. So 20 is equal to a negative 156 cosine of C. So I get 20 is equal to a negative 156 cosine of C. To continue solving this, let's divide the 20 by the negative 156. And I'm not going to actually divide this. I'm just going to write it. I'm not going to compute it. So 20 divided by 156, so that's a negative fraction. That's equal to the cosine of C. And to find C, we're going to do the inverse cosine. So C is going to be the inverse cosine of a negative 20 over 156. And that results in an angle of 97.37 degrees. So that's angle C. Let's do the same thing. We can go ahead and do it for angle A since I already wrote the equation out. So A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So if we plug our values in there, we will have 13 squared is equal to 6 squared plus 15 squared minus 2 times 6 times 15, and then times the cosine of A. Again, 13 squared is 169, 6 squared is 36, 15 squared is 225, and then 2 times 6 times 15, well, the 2 times the 15 is 30, and 30 times 6 would be 180. So we have 169 is equal to 36 plus 225 minus 180 times the cosine of A. And we'll follow the same algebraic process. We're going to take the 36 and the 225, and we're going to subtract them both from the 169, and that's going to result in a negative 92 equaling a negative 180 cosine of A. And then I'm going to divide both sides by a negative 180. So you have a negative 92 over a negative 180 equals the cosine of A. The negatives cancel out. I'm not going to do the division now. We can just let our calculator do that. And so I need to get A isolated. I need to take the inverse cosine. So we're looking at the inverse cosine of a positive 92 over 180. And that results in an angle of A equals to 59.26 degrees. Okay, so I know angle A and angle C. So the last piece is angle B. And again, just like we've seen with all sines, we know the sum of the three angles has to be 180 degrees. So A plus B plus C has to be 180. And so that means B is going to be 180 degrees minus 59.26 degrees minus 97.37 degrees. Those are the two angles that we just computed. And so if we do that subtraction, 180 minus 59.26 minus 97.37, we should end up with an angle of 23.37 degrees. Okay. And again, hopefully those three angles add up to 180. You can double check that if you want, but it looks like that would work. We could also do the same kind of thing that we checked with law of sines. We could make sure that the longest side corresponds to the largest angle. So the longest side was side C at 15, and angle C is the largest angle, right? So that still works. Again, one thing I do want to point out here, sometimes with law of cosines, when people do solve law of cosine problems, once they've done law of cosines once, so they have enough information, they will actually switch to doing law of sines. And I really want to caution you from doing that. Just to quickly illustrate why. Say we had found, after we found angle C, and we still needed to find angle A. Let me redraw that picture and look at the information that we would have to use to figure out angle A. So if I'm going to use angle C is 97.37, and I need to use side A, which is 13, and I have to use the side C, which is 15. Okay, that would be the ratios that we would need, right? Because we'd have to do sine of A over A is equal to the sine of C over C. If you look at the information that we have right here, that is using, to find angle A, that would be using two sides and the angle that's not between the two sides. That means you're starting to look at a side-side angle situation. We don't want to do that. Okay, it is possible to do it as long as you know what you're doing and you look at the right values and you can kind of determine, do you have a triangle? Do you have only one triangle? Because we don't want a second one. We only want the one triangle situation. Well, if there's two, you have to know which one is the right one. Okay, so again, I just want to caution you, don't do this. Okay, if you want, other people can do it, and that's their choice. But I would really, really, really encourage you not to do that. If you have a law of cosines problem, solve it completely with law of cosines. Do not switch to law of sines.